Good afternoon, everyone. Welcome to the Lunch and Learn hosted by Wavelogix. My name is Suzanne Florick, and I'll be your moderator today. We're thrilled to have you join us for this insightful session on revolutionizing concrete strength and monitoring with the AASHTO T-412. Before we dive in, let me review a few housekeeping items to ensure you have the best experience today. This webinar is being recorded, and a copy of the recording and any presentation materials will be shared with you via email tomorrow. For the best viewing experience, we recommend using the gallery view. You can switch between the views in the upper right corner of your Zoom window. We've prepared a quick poll for after the webinar to gather your thoughts and feedback. When it pops up on your screen, please take a moment to participate. It is anonymous. Please use the Q&A feature at the bottom of your screen to submit any questions you have during the session. We'll address them during the Q&A portion at the end of the webinar. If you encounter any technical issues, let us know on the chat, and our support team will assist you. Feel free to engage with us. We use that chat function to share your thoughts, but please ensure all your messages are sent to everyone for all participants to see. Now it's my pleasure to introduce you to Wavelogix and our distinguished speaker for today. Wavelogix was founded in 2021 in partnership with INDOT at Purdue University to improve road and bridge reliability while reducing traffic disruptions. The Rebel Concrete Strength Sensing System provides real-time, in-place measurements of concrete properties, offering a more precise and versatile solution than traditional sensors. With patented technology, Wavelogix eliminates the need for preset maturity curves, delivering accurate results across various projects and helping teams optimize schedules and reduce costs. Joe Turek is president and COO at Wavelogix. Joe received a bachelor's degree in electrical engineering from the University of Notre Dame and an MBA from Northwestern's Kellogg School of Management. He's been involved in manufacturing his entire career. He holds 5 patents involving high-performance microwave telecommunications circuit board technologies, and he is a registered professional engineer and a member of the IPC and the IEEE. Joe will be sharing insights on revolutionizing concrete strength with the AASHTO T-412 today. Please join me in welcoming Joe. With that, let's get started. Joe, the floor is yours.
Thanks, Suzanne. I really appreciate that. And welcome everybody to our last in our first series of 6 seminars giving you specific information on our Rebel sensor system. Today, to finalize our series, we're going to talk about the AASHTO T412 specification. Starting off, first of all, for those of you who don't know what AASHTO is, it's the American Association of State Highway and Transportation Officials. They're the governing body that creates all the specifications for the Department of Transportations on all 50 states. Today we're going to be talking about the test method that was approved in July of last year, the T412 test method. So if we talk a little bit about the future of strength testing using the T412 test method, it is classified as an acoustical resonance method, and it determines in real time in-place strength of concrete as it cures. This is a shift from the traditional standard that uses cylinder breaks to now use a more real-time accurate testing method that we expect increases the contractor's return on investment. We're excited to also be working with Massachusetts DOT, who is the first state in our nation that adopted the T412 into their concrete specifications. And we'll talk about that a little bit in this presentation. Just to review, why is knowing strength critical? Because, we use it in a lot of applications. We're removing forms, knowing when the concrete is strong enough to start removing those forms so the structure doesn't fall apart, removing scaffolding as well on multi-floor buildings and garages. Post-tensioning, a lot of bridge decks and garage decks use post-tensioning of the concrete. You need to know a very specific window of strength of when you could do that, or you'll damage the concrete in the process. Releasing traffic and horizontal work on both bridges and on pavement. Segment pouring, if you're building a column, a wall, and you're doing it in sections, you want to make sure the lower sections are cured enough, have enough strength to take the new weight of concrete that's being poured upon that. Panel lifting is another example in tilt-up applications. I think a lot of people have seen warehouses using tilt-up panels, and if that concrete isn't strong enough to tilt them up, they're going to crack in the process. So strength, and specifically early strength, a lot of times is very critical in concrete applications. The traditional method today in almost all the specs in the AASHTO world are T22, and that comprises the test specification for compression cylinder brakes and flexural beam brakes, things that we see most used in DOT for specifying final strength. The disadvantages of this type of process is that it's labor intensive and it requires skilled technicians. Early strength under a day is not really possible. The concrete cylinder is not strong enough to actually crush and give you reliable results. It's also a periodic process, testing at intervals of 1, 3, 7, 14, 28, today maybe even 56 days, rather than real-time monitoring. There's a high potential for error, sometimes as much as 500%, depending on how you make those cylinders. If you're not following exact precise process, or there's air entrapped in the process, or it's settled too much, you could get errant results when you go to crack or crush the cylinder or break the beam. There could be time delays while you're waiting for your cylinder to be broken to be able to determine if you have the right strength. And if you don't meet the strength at, let's say, 1 day, then you might have to wait to 3 days to see if you hit the strength. And it's a resource-heavy process. Uses a lot of equipment, a lot of cylinders in that process. The benefits of our new technology using T412 compliance is that it's real time. It's our device, the Rebel sensor, meets and complies with T412. Some of its key points and benefits are that it's calibration free. You can use it on any type of mix design. It's not dependent on temperature. It's not dependent on the moisture of the mix. It's real time. It monitors the concrete strength. You can go from 56 days and beyond. So it truly it can go the distance as a sensor. Proven reliability. It's very low variability than cylinders and beams in core tests. So we have been testing the sensor for 3 years, and we've gotten very good, accurate results. There's no question that it saves cost and time. We can help contractors complete their projects faster. We can help them get paid earlier if they're getting paid on final strength. It's easy to deploy with non-skilled personnel. And as I said, it's fully compliant with the new 412 specification. Just to give you an idea how it's being incorporated into specs, we have a slide here from Massachusetts DOT's specification, and you can see that they are using the classic T412. C1074 is maturity sensors, but they've now added in the AASHTO T412 for compliance. And this is for concrete that is fast curing concrete, which is something that you want to know early strength. So 24 hours, 3 days, 7 days, meeting specification. So it's really great for using this. And you can also see for rapid hardening, 4 hours, 24, and 7 days. So this is really significant, something that you really can't get from the T422, excuse me, the T22 specification. You could get some poor results with compressive strength cylinders. So that's kind of exciting with this. Also, let's see to this. If I close that out and go on to the next one. On our next slide, oh, that's kind of interesting. Kept that annotation in there. I am going to just remove this right now to do that. Okay, I thought I'd get fancy, but that didn't work out too well. So in also with the MassDOT, they have general specifications for precast and pre-stressed concrete. And again, you could see that they're using the T412. And in precast, it's very important for times when you can remove your forms, when you're going to do the release of the pre-stress strands, very important. Pre-stress, if you're not familiar with that, they pull strands of fibers to very high tension, pour the concrete over those strands, and then once the concrete is cured to 80% of the finished strength, then they release those strands. If you release it at the wrong time, you can end up cracking the concrete. And then the termination is 100%. So again, T412 is a process that can be used for this. And now finally, what we call the best application is using it for your target strength, 28-day strength. T22 is only approved for final strength in MassDOT, but they did leave a little caveat here that subject to department review and approval, in-place non-destructive tests may be used as an alternative to T22. So they're leaving the door open for us to potentially use our Rebel sensors for final strength. But what MassDOT is looking for is more contractors using our sensors and seeing what the data looks like. So there's hope that we can have the holy grail of completely eliminating cylinder and flex brakes and just using the T412 standard and our Rebel sensors for strength throughout the curing process in concrete. Why AASHTO 412 matters? And one is that MassDOT is integrating it. So just to understand what happens with the specification, just because we have a standard that was approved by AASHTO, that allows the states to actually use our sensors in their specification. But we still require the states to actually write T412 into their specs, like MassDOT has done. So this is what happens when anytime there's a new spec that comes out, then every state has to adopt it. What's great about 412 is that it's non-destructive. It gives you accurate strength, and so you see that in real time. You can start predicting the strength at 28 days in as little as 3 days. That's the beauty of our sensor system. But we are looking for it to be adopted across all 50 states. We're right now actively engaged in 35 states that are heavy into concrete paving and bridge work and getting them to adopt our specifications. So we need the help of contractors to talk to their DOTs to ask them to approve the T412 specification. And we're actively pursuing them as well, giving them information. We have data pack that puts together 50 pours through around the country on DOT projects that can help the DOTs believe and approve our specification. Some of the key benefits of having our sensor system in place in the horizontal work, specifically with the DOTs, you can accelerate traffic or accelerate the release of traffic onto the roads. We can potentially eliminate cylinder and beam brakes. And we could help get contractors paid early by showing them when they've reached the final strength. In vertical applications, saving time and improving efficiency, we think they can save over 50% of the cost by using our sensor system. In slab work, like in warehouses, we can give flexural strength that helps improve the flatness of their process when they can go in there and start to smooth out the concrete. Tilt up, as we talked before, knowing when you can safely tilt up those panels without them cracking. Geotech houses are starting to use our sensors by replacing cylinders with our sensor system, going to their contractors and managing the process of implementation of our sensor technology. Ready mix companies are starting to use and adopt our sensors for quality control, the batch that they make, validating that the mix meets their required specifications and cures properly. So we have a really cool cylinder sensor system that helps ready mix companies do their QC. Precast, as we talked about, and pre-stress, great way to optimize the removal of the forms and keep product moving through their factories. And we've been introducing this internationally. We've already started with India and working on other countries around the world. If we just look at the cost breakdown and how our costs compare to cylinder brakes, if you look at braking cylinders or flex beams, you typically have about $400 in labor. Transportation costs adds another $100, moving the cylinders of the beams from the field to the lab where they have to be compressed or crushed. The cylinder costs themselves, typically, if you're doing a set of 15 cylinders, it's going to cost about $375. The lab fee is usually another $100 on top of that. And then final reporting, profit, and overhead adds another $400. So in general, the round number cost of doing about 15 cylinders for the cylinder set is about $1,375. Now, if you compare that to the Revel sensor system, and versus the cylinder brakes, you've got about $100 of labor, very simple to deploy. If you assume two sensors per pour, the sensors are $200 a piece, that's another $400. And overhead profit usually would represent another $200. So our overall cost in our sensor system runs about $700, saving about 50% compared to compression and flex spring brakes. If you look at the setup, you can literally just throw the sensor on the ground and pour concrete over it, or you could tie it to rebar. And as long as there's no rebar directly over the surface of the sensor, that sensor will work perfectly in the concrete. It doesn't have to maintain any distance from the surface of the concrete. There's no moving that data, with a beam or an antenna. Everything can be anywhere in the concrete structure. Just a quick overview of our system. It's represented by a sensor. It's a 4-inch diameter sensor. It has our piezo wave generator in there that creates the acoustic wave to measure the strength, along with a temperature probe. So we're very similar in this respect to a maturity sensor that has a temperature probe along with our wave generator. The sensor has a cable that comes out of it that gets plugged into the data logger. The data logger is one data logger per sensor is plugged in during the time that the sensor is taking its readings. Inside the sensor is an impedance meter, a GPS location chip, so we know right where the sensor is located, has a cellular radio that as soon as you plug in the sensor, connects up to the cellular infrastructure and is sending data from the sensor to the cloud into our database. There's a lithium ion battery inside the data logger that has a 28-day capacity. That battery then is wirelessly recharged in a cradle charger. It's a sealed case, so it can actually work underwater, no fear of damage from rain or puddles or any type of environmental issues. It's got a very durable housing. It can withstand environmental pressures and a lot of beating up, if you will. Uh, the system overall, once you place the sensor into the ground, the data logger connects up through the LTE cellular network, connects data, gets sent to our database. We have a machine learning algorithm that works on that data, converting the data from the sensor into a compressive strength. And then we show that on our dashboard along with temperature. And then the user can see it on their phone, on their computer, on a laptop, on a tablet. Lots of interfaces in there, anywhere that you can just connect up to the web. A closer look at the dashboard gives you time versus strength. You can set test alarm points if you want to know a specific time when something gets to the strength that you're looking at. You can set strength alarms, which is very convenient if you're doing things like removing formwork, but specifically, let's say, post-tensioning work. And then we also supply the temperature in the structure, and we have another thermocouple inside the data logger. The data logger is outside the structure. The sensor is in the structure, so you get both a comparison of the temperature in that structure and then what the outside environment looks like. So really important if you have a really hot day or a really cold day. It's nice to know what that temperature is externally and also to know the temperature of the structure so that if you needed to cover it or heat it or cool it, to keep it conforming to the specifications as designed. And uh, as is true, we want to just have a very quick, brief overview. And thank you for listening to this presentation, our last in this series. We have a great new series coming up where we're going to have panel discussions with industry influencers over the next quarter. So those sessions should be a lot of fun as well. Right now, I'd just like to open up this presentation to questions. Suzanne, fire away with anybody who has anything more to ask.
Sure. Nice work, Joe. We enjoyed that. Well, we have a couple questions that came in here. One was, how can your product be utilized in a test house? Will it fit in a cylinder?
Yes, the we have a special cylinder that makes it convenient for a test house to use it or anyone in the lab. It's a 6-inch by 12-inch standard cylinder, and we mount the sensor in the bottom of that cylinder, and then all you have to do is pour about 6 inches of concrete over the top of that sensor. If you don't purchase that cylinder sensor, you can take our sensor and you can drop it into a 6 by 12 cylinder yourself. Although the sensor itself is 4 inches, we don't recommend putting it into a 4 by 8 cylinder, which is another standard cylinder, because there isn't enough concrete around the surface of that sensor to give you an accurate reading. So 6 by 12 is a way to go. You can also put it in a beam. You can put it in a pail or a bucket. Doesn't really matter. As long as you have about 4 inches of concrete and 2 inches of concrete around the sensor, it'll work just fine in that type of product. You do not have to pour a structure.
Okay, great. Thank you. Um, does the technology calculate flexural strength?
Uh, yes, we offer in the very near future, we're going to offer the data in 3 different modes. Right now, we're offering compressive strength, but we'll also have a button that you can press to have it show you flexural strength, or a button you can press to have you show modulus. So between those three, it satisfies just about any need in the industry: compressive strength, flexural strength, and modulus. And civil engineers can figure out things with the modulus, and folks that are used to using Flex will have that data as well.
Okay, thank you. Another question is, what are challenges companies face when going from traditional methods to T412 compliant systems?
So there's not a lot of problems, in effect of how to use it. But I will say straight up right now, so far, no one has approved, even with the AASHTO 412, approved our sensor to be used for final strength. So That means that if you're looking for final strength verification or certification, you're still going to have to do a cylinder break. But what our technology allows you to do is tell you when to break that cylinder, because we can tell you what the strength is and when you've hit final strength, and then at that point you can do your cylinder break. We have been approved with Mass DOT, Massachusetts Department of Transportation, the ability to use 412 for early strength, so you can eliminate the cylinders or flex beams during that period of time for early strength. So the nice thing is that right now you can severely minimize the number of cylinders that you need to use if you were going to need to certify it for strength. And so that optimizes the cost, and you use our system to tell you when to break.
Okay, thanks, Joe. We have one question that came in. How thin a concrete slab can you use this on?
So we would like to see at least 2 inches of concrete over the surface of our sensor. Um, 4 would be better, but 2 is kind of the minimum. So if you were doing an overlay on asphalt or on concrete, you could lay the sensor right on the surface. And then as long as you were pouring 2 inches or more of concrete over that surface, you're going to get a pretty good accurate reading.
Okay. By the same person, is there any experiment to show the test results for super heavy reinforced concrete?
Um, we've done a lot of testing. We've had a lot of bridges that have a lot of um, rebar in it. We have columns that have rebar in it. I'm not certain what is referred to as super heavy, but if you're talking about mass concrete, um, and deep in mass concrete. We don't have data yet for mass concrete, but we have a lot of data for rebar. And rebar does not affect the sensor reading as long as I mentioned, the rebar is not directly over the surface of the sensor. As long as it's above the sensor by at least 4 inches, you'll get an accurate reading with our strength meter.
Okay. Thanks, Joe. It looks like we have about three more questions here. The next one is, does this need to be calibrated for all regions? Is the machine learning ready to go for any region?
Yes, we believe it's good for all regions. We have tested it across the country, are now testing it outside of the United States. But because our process is using the actual strength of the concrete, we're looking at the modulus. We use an acoustical resonance method that looks at the resonant frequency of the structure itself, and that then correlates directly to the modulus, and the modulus correlates directly to the compressive strength. So it's independent of the type of aggregate that you use, where the aggregate comes from, how much moisture is in that, any type of additives, any type of fiber. Whatever you put into your mix to cause strength, we are measuring the true strength of that mix. Therefore, it doesn't need to be calibrated around the country. Now, our machine learning has been working and learning on and calibrated, if you will, to a broad ranges of mixes, but there are some mixes that are outside of that range right now. And all we would have to do is make sure that we learn on that. So it still is a learning process. And anyone who has something that's unique, we'd be happy to work with them to develop our models to incorporate in that type of mix design. But so far, we haven't been stumped.
Okay, perfect. Will it work with C 1600 cement concretes?
Uh, Honestly, I apologize, but I don't know what that what that cement is. But we have been working with cement that is fast cure. Uh, we've been working with cement that is has
It,
limestone in it.
excuse me, Joe. The question was posed for CSA cement.
Okay, CSA cement. Um, Again, I'm not absolutely certain of that cement, and that's something that I would ask them to contact our sales department to get to our tech people to talk about exactly that. But We have done fast cure cement. We have done um, uh, cement that has limestone in it, low carbon types of cement we're working with. But the only thing we haven't worked with right now is very high strength cement. So anything that goes above 8,000 PSI, we haven't calibrated our models to that type of strength. Everything else in between seems to work, but with anybody's design, we really ask them to try it out and see what type of results we get compared to cylinder brakes. We do, if I put a plug in, we have something called the 1-2 punch, which is a free set of two sensors and a data logger that allows you to try it for free. And then we work with you to move on from there. So if anyone has any doubts, we have a way for you to do it on a risk-free basis, so to say.
Okay, perfect. The question is, how common is T412 in the industry? It doesn't seem widely accepted. Any progress with ASTM approval? Does ACI accept your product?
Really good question. So it we were working directly with the DOTs when we came out with this product. They helped us get it through on the fast track, and it got approved for an AASHTO test method in July of last year. So we've only gone 6 months where T412 has actually been published, and so now we're actively working with all 50 states on trying to get them to adopt T412 into their test specifications. MassDOT was the first one to do it. We've got several more. We think 10 more DOTs in the very near future, in the next couple quarters, to adopt that. But it really takes people using the sensor to be able to show that it can be used in your area. And the DOTs want to hear from contractors, to hear contractors say, we love it. It works great. We'd like to eliminate cylinder brakes. As a matter of fact, we're not certain there's anyone who loves cylinder brakes or flex beam brakes. So it's a great advantage to have something that's better than maturity sensors, which only work on temperature, and something that truly works on strength. We do not have an ASTM or an ACI standard. Those standards, frankly, take about 5 or 6 years, anywhere from 3 to 6 years, and they require a lot more use in the industry for them to even start to consider it. So we're not going to see that spec for a while, but if you're using a sensor for early strength, you don't need a standard for those actually. So it's going to come through use. We're going to pursue those other standards, but it's going to take time to get there.
Okay. So our last question, Joe, for the day, somebody was wondering your comments on this. The statement is the procedure in T412 does not refer to using cloud to estimate strength. It uses an empirical equation that calculates strength from a computed elastic modulus. Do you have comments on that?
Yeah, that's exactly kind of the method that we use. We have to take the data and send it up to the cloud to allow our algorithm to actually do those types of calculations. There is no, let's say, brain. It takes a lot of power to decipher the information that comes out of the sensor. And so that's all done in the cloud. A lot for protection and to guarantee the quality and the accuracy of the data that we're presenting. But the specification for T412 does require the data to be available, which we make available for both modulus, compressive strength, and flexural strength.
Okay, great. Well, that brings us to the end of our session today, just to keep us on time. On behalf of Wavelogix, I'd like to thank you, Joe, for all your valuable insights, and thank you as well to all of our attendees for your time and participation. We hope you found this session helpful and informative. A quick reminder, the recording and presentation materials will be shared with you soon, tomorrow. Have a wonderful day, and we look forward to seeing you at our next Lunch and Learn on February 13th, Thursday at noon. So thank you all.